Hello, Assalamualaikum. My name is Rabiatul Adivia binti Zulkifli. Nombor metik 2013711562 and I am from Electronic System, which is UR 6523007. I'm gonna present about subject NMK 21303, Lab 3 Operational Amplifier, Comparator and Summing Amplifier. Okay, first of all, for this slide, I'm gonna present about the comparator, which is zero level detector. Zero level detector is a basic comparator, which is when the inverting input is grounded to produce a zero level, and for the non-inverting input is connected with input signal voltage. You can see it connect to the 10 volt for this in this circuit, and the positive volt and the negative is supplied from the DC, which is 15 volt. When the sine wave is positive, the output is at its maximum positive constant level. At the right side is we can see that the signal output and also the signal input from the circuit of the comparator. For the cursor 1 show that the input of the voltage input, and for the C2 is show us the voltage output of the circuit. At the below of the signal, we can see that the input is 10 volt and the output is 13 volt. Why? And when we see the signal, the output is like a square wave. What? Because the voltage supply is the maximum is 15 volt. So when the output is exceed by the power supply, and it will clip the signal. Next is a comparator, also comparator, but non-zero level detector. It has 3 types, and for this lab we use a voltage divider reference, which is to detect the positive and negative voltage. A fixed reference at here is connected to the inverting input. We using a voltage divider to set the reference voltage, which we use R1 and R2. Okay, and as we can see this under the circuit diagram, this is the calculation for the voltage reference. For the calculation, we get the voltage reference is 2.63 volt. And at the right side, we can see that the signal output, the signal input, output, and also the voltage reference for the circuit. And at the pink line, this show that the voltage reference at here is matched with the voltage reference from the calculation, which is the experiment is 2.63 volts. This is another non-zero level detector, which is in the same as the previous circuit, but in the previous we used 4.7 kilo ohm as the value for R1, but in this circuit we use R1 2 kilo ohm. As you can see that the line of the output of the RF is in line with the cursor 1, which is input signal, and the output is negative 12.978 volts. If you compare with the calculation for voltage reference, the result is matched with the uh, experiment of voltage reference, which is 4.999 volts. In this circuit, we put the R1 value is 1 kilo ohm, same as R2 1 kilo ohm. Uh, is same as previous the circuit, and the right side we can see that the voltage reference for 1 kilo ohm for R1 1 kilo ohm, the voltage reference is 7.4999 volts. We can compare with the calculation result is mesh 7.5. If you compare with the previous circuit, which is R1 4.7 kilo ohm and R1 which is 2 kilo ohm, if the R1 is decreased, the value R1 is decreased, the voltage reference is increased based on this experiment. In the previous slide, we learned an experiment about the comparator, which is zero level comparator and also non-zero level comparator. In this slide, we experiment about summing amplifier. Summing amplifier, what is it? Is it accept two or more input to produce one single output. In this circuit, we use R2, R1 and RF with the same value, which is 10 kilo ohm. On the right side, we can see that the output signal of this circuit is 2 volt. You can compare with the voltage output from the calculation, which is under the below the circuit. We can see that the voltage output of calculation is in negative form, which is negative 2 volt. But in the experiment we conclude that as a 2 volts voltage output. In this slide, we experiment the same summing amplifier, but we change the R2 from the 10 kilo ohm to 2 kilo ohm. The value of RF and R1 is same as the previous circuit. We can see at the right side, the output signal is higher than the previous circuit, which is in the previous is 2 volts, and in this circuit we can see that the voltage output is 6 volts. We compare with the calculation, the voltage output is matched with the experiment, but in the calculation it in negative form, which is negative 6 volts, but in the experiment is 6 volt positive. In this lab, we have 2 questions. The first one is, what do you understand about summing amplifier? Summing amplifier is an inverting amplifier that accepts 2 or more input voltage into a single output voltage. It can accept how many input there are in the circuit, and it produces only a single output signal. The second question is what happens to the output if the frequency of the source is increased 3 kHz. What if we increase the frequency, it will result a smaller distance between each of the consecutive line. In this slide, we have two discussion where we discuss, there's discussion A and B, and we also have discussion C. Discussion A and B is about the comparator. The comparator is an OM circuit that compare two input voltage and produce an output indicating the relationship between them. The basic of comparator is zero level detector, which the inverting input is ground to produce zero level, and the non-inverting is connected to input signal voltage. When the sound wave is positive, the output is at the maximum positive constant level. The other one is non-zero level detector. To detect positive and negative voltage, a fixed reference voltage source, which is VRF, V reference, is connected to the inverting input using a voltage divider formula to set the reference voltage. In discussion C, we discuss about the summing amplifier. Summing amplifier is an inverting amplifier that accepts two or more input voltage into a single output voltage. The output voltage is proportional to the sum of the input voltage. If RL is the same value as R, then the amplifier is called summing amplifier with unity gain. When RF is larger than R, which is mean the value, the amplifier has a gain of RF over R, and it's become a sum amplifier with gain greater than unity. Last but not least, the comparison from this lab, we can conclude that in this lab we learn about comparator and also the summing amplifier. In the comparator application, the OM is used in the open loop configuration with the input voltage is fed to one input and a reference voltage on the another input. In summing amplifier, it uses an inverting OM configuration. It accepts two or more input, and its output voltage is proportional to the negative of the algebraic sum of its input voltage. That's all from me. Thank you.